Hi everyone, in this video we'll talk about continuous random variables. Now let x be a continuous random variable. So I'm just going to write continuous RV, standing for random variable. And when would x be a continuous random variable? So when x, the set of values, possible values that x can take is uncountable. So you can't count it. If it was countable, it would be in a discrete random variables. It's uncountable, then it becomes a continuous random variable. And for a continuous random variable, there has to exist a non-negative function fx. Okay, that's what is necessary for a continuous random variable. A non-negative function fx, which is defined for all real x. For all real x, element of negative infinity to positive infinity. Okay, and if you take any set B of real numbers, okay, any set B of real numbers, that is, you look at some set of numbers, say maybe between -3 and 5. Okay, that's a set of real numbers. We will have this thing defined. That's what we'll call as the probability. The probability x element of this set. Okay, say between -3 and 5. Okay, and that you can get by integrating fx over dx, this set B. Okay, so integral of fx dx over this set B of real numbers is going to give you the probability that x, this random variable, falls in that set of real numbers B. Okay, now this fx is called probability density function. Now recall that for a discrete random variable, fx, or the probability, was called the probability mass function. This is its counterpart for a continuous random variable. It's called probability density function, or PDF. Okay. Now to get the probability, what you are doing is you will integrate the PDF, which is fx, over that range. Okay, so naturally, if you integrate fx dx between -infinity to infinity, that is all possible values that x can take, you will get the probability that x lies between -infinity and infinity, and that probability is going to be 1. Okay, so as we expect with probabilities should add up to 1, and that's what is happening here. Now if you want to find the probability that x lies within a certain range, say probability of a less than equal to x less than equal to b, that can be simply obtained by integrating fx dx between a and b. Okay, and one thing to note is that the probability at a particular point, that is because it's a continuous random variable, and you can take a whole bunch of values, uncountable number of values, at a particular point that x takes this value a is going to be 0. Okay, you can just get that by substituting it in this equation. Okay, so for a continuous random variable, assuming probability of x taking a particular value, that's very, very important, a particular value is 0. You can't expect x to take a particular, because the uncountable number of values. Okay, so that is something to keep in mind. So what have we studied so far? We looked at What is a continuous random variable? We studied probability density functions, which is PDF. Then we looked at that the probability should add up to 1. And then we studied that probability at a particular, taking x in a particular value is 0. So these are the things that we've studied so far. So now what are we going to study? We're finally going to talk about cumulative distribution functions, or CDF. So cumulative distribution functions. That is, to get us the CDF for continuous random variable, what do we have to do? That is got to be defined by f of a. That is, x takes a value less than equal to a. So that is essentially nothing but x being in this element of this set minus infinity to a. And it does not matter, it's actually close in this way. What we can do is we have to just integrate between negative infinity and a, fx dx. Okay. Now that's how we get the cumulative distribution functions. And you just want to remember one thing, that if you differentiate f of a, that is capital F of a, with dA, you will get fa. So the CDF, if you differentiate, you get the PDF. And if you integrate the PDF, get the CDF. Okay. So this is something very important to remember, how the PDF and the CDF are related. You can get the PDF from the CDF and vice versa using differentiation and integration. So just to recall all the things that we studied, we started off by defining what is a continuous random variable, and we looked at what is fx, that is the probability density function. Then we said that if you integrate the probability density function, all the probabilities just add up to 1. That's what we get here. Then we talked about probability of x taking a particular value will always be 0. Then we finally discussed the CDF, or the cumulative distribution